Hello everyone, so here comes the requested reveal of the secret behind this self-navigated maze that I did in Excel. So I'm going to just provide a little bit of explanation to go along with the file that I will be sharing as well. So I'll start from the end. So basically, I've got 4 separate samples. All of them have got their own set of formulas, which I will go through a bit later. And all of them have got their own spin button to just for the presentation purposes. Oh, that's annoying. But for just to make it look cooler, I combined the 4 samples together for the final presentation. So all of those spin buttons are temporarily linked to this one, so I can do the presentation simultaneously, run all those 4 examples at the same time, and these are actually just copies of these, and the formatting. This is probably just an error. The formatting is, I believe, it's also linked to the individual tabs. So it's basically just a mirror image of what's happening here. Because if I run this control, and if I look at any of those tabs, action will be here, and this is just a mirror of it. So okay, so that's it. Okay, so let's go through the formulas and the process of how I conquer this puzzle now. So we have a maze. It has to be a proper maze, meaning there has to be just one valid route. It cannot have multiple options, because otherwise the route, the formatting will just spill all over the place. So how to build that maze, I will do a separate presentation on. But okay, so my starting point, I think actually for this puzzle I never used these, but my starting point with grid-based puzzles tends to be marking the rows and columns, like giving the numbers, because very often I do actually use them and refer to them. So this is like a step 1 always, but I don't think I actually used it in this case. So let's move, because there are no dependents. So let's just move forward. So first thing I was checking for is to mark the top and the bottom of the first thing I did was to identify all borders or walls. So if you look at the outer frame, it's got an F in there, because I used it to, if there is nothing, then there's no wall, no frame. So for outer frame I used F, and for walls, inner walls, I used B. That can obviously be anything. Because I wanted to do it without VBA, I couldn't use the border, the actual borders, cell borders, as borders and walls, because well, at least I'm not aware of a formula that would detect those without VBA. So instead I build the walls by just conditional formatting and letters. So I'm identifying whether each cell, whether it's got a top, which means does it have, so for each cell I'm checking if it's got a wall surrounding it on top of it. So this one has got a top, this one obviously doesn't, because we can go up. This one will have top wall and right wall, and so on. So I'm checking just for top walls here, then for bottoms. So I'm checking if this cell has a bottom, yes. So it's either 1 or 0. Likewise, I'm checking if it's got a wall on the right side and on the left side. And the next step is to once I've got that, I'm checking if from any position, so I will be probably using now these, if I remember correct. I don't actually remember how I did that. Trace the precedent. Yeah. So I'm using those. Am I? Once I have the borders marked for each cell or identified, I'm going to again go into each cell and check if we can go up, like in how many directions we can go from this cell. So from this one we can go up or down. From this one we can go back, back to the start, so right, up, or left, or down, and so on. This one is also up, left, right, and so on. So again, I'm checking one by one. So I'm creating a separate matrix just to check if we can go up from each cell, and I'll mark it with U. So this one is this one. So yes, we can go up from here. We can't go up from here because it's a border. We can't go up from here. So that's how it works. And then just like that, I'm checking if we can go down from each cell. From each empty cell, obviously, I'm not checking if we can down from whilst being inside the border, because there's no point. And I'm checking if we can go right, and I'm checking if we can go left. And then I'm combining the results with in one matrix. So I'm going to mark anything that's a border or a wall with an X, and I'm going to combine the results of these previous steps, like can we go up, can we go down. So I'm going to just combine all possibilities, and if there is more than one, it will give me a spill error, because if I clear that, you will see that from this cell we could go down, right, and left. But because there is no space, because I'm checking every single cell, this is now wrapped in the inside the spill error, but I don't care, because I'm only interested at this stage in what's a border and what's a cell that's got only one, which is in other words a non-error cells, which have got only one option to go. So like this one is this one, so I can only go in one direction. In this case it's up, but it doesn't matter, because every time I can go only in one direction other than from the start, it means I'm at the dead end. There's no, I can only retrace. I cannot go up, right, or down from here. I can only come back to where I was. So that will help us to identify the dead ends. So once I've got the first set of the very dead ends identified, all of these have been identified and are marked as either U, D, R, or L, which means just one direction. And for simplicity now, I'm going to ignore what direction it is, because it doesn't matter. It only matters that it's a dead end. So I'm now replacing all those one-way options with X's, which means so as if I was kind of blocking this. I'm no longer interested in this cell. I kind of marked it as dead end, and now I'm looking at new maze, which looks like this without those. So all these will be blocked, and I'll be just checking. So the maze will be becoming kind of smaller and smaller until only the final actual route through is revealed. Let me just undo this. So all the initial dead ends are marked X, and then before I start iterating, I'm just cleaning everything up and putting everything in place. So the frame and the inner walls are marked as just they are basically empty. All the empty cells, which are not borders and not frame, are marked with E, and the dead ends are marked with an X. So so these are the dead ends, which kind of becoming new walls, additional walls, because just as I just presented with the colors, the maze will now be getting smaller and smaller. So I'm interested in the number of dead ends, because every iteration will bring more and more of them, because once this was dead end in the first iteration, so now maybe this is not a good example. Let's just do. So our initial number of dead ends is 44, and so this one, let's say this one was identified initially as dead end, because it's the very end dead end. So in the next iteration we will be checking for again can we go in how many directions can we go from each cell, and from this cell now we can go again only in one direction, because this is now blocked. This is kind of we've put some like another wall here, so we cannot go in here because we already know this is a dead end. We can only go left, which means we can only retrace, and that now becomes a new dead end, and so on. So this will not be a dead end because we have two options to go from here. We can go back to wherever we came from. I think in this case we will be coming from this way, or we can continue going. So this will never be dead end. So there will be no more kind of blocking in this area. So this process will continue. So now I'm basically keep doing. I called it recursion. Basically, I'm just iterating. I'm repeating the same process again and again. But now every new every dead end identified in previous step is now treated as a wall, and there will be more and more X's and less E's, which means the empty cells that actually are candidates for the route through. So I'm counting that because I keep iterating until that number doesn't change, the count doesn't change, which means no more new dead ends are being identified, which in theory should mean there is only a proper route through left. So I kind of I think I allowed up to 20 iterations, because I kind of estimated how many it will take for this sample, because the idea wasn't to solve every single maze in the world. The idea was to solve this particular puzzle of this size. So for bigger sizes there will need to be probably more iterations, and obviously the matrices would need to be bigger, but that wasn't the purpose of this exercise. So I'm repeating. Okay, so I'll go. The number of dead ends increases, increases. And I think at some point it starts when it got to, in this case, 143. Obviously the number is not relevant. So we got here, iteration number 9. It found 142 dead ends, and in the next one only found one more, and finally it didn't find any new ones. So this is my stop, and this is basically nothing new is happening here because I just allowed for up to 20 iterations, so nothing will be happening until so this is the final stage, which is exactly the same as stage iteration number 9. So at this point the route is actually revealed by the E's. This is our route through. But if I just simply, which I did originally, if I just simply conditionally format this now to to highlight all the E's, the root will be revealed instantly. We can actually do this, and it will just not have that effect. So let's just quickly do it. Not sure what I'm doing. Okay, so let's just jump straight through like number 1. So that's no fun because it revealed the root straight away, but I want it to be revealed like this, one by one. So in order to do that, I had to number, because these are our E's in that final stage. So this is a E, and I wanted to count, like number them. This is E number 1, this is E number 2, E3, E3, and so on. So I kind of did it. Again, I had to create a lot of grids to do that, because I couldn't. Perhaps there is a way, smarter way of doing this, but I couldn't number them all within one formula. So I hard coded the start because I knew where it was. So this is the first E, and then around this I just in the surrounding cells, not diagonally but just directly above and below and to the sides, I put a formula that searches for the next, the neighboring E. So it will tell me which E is number 2, and then this I think from this point here the formula was only in these cells, and now I can actually do the formula everywhere, and it works just reveals the E's one by one. So here it will reveal the third E, then it will reveal the fourth E, and so on, as you can see. So this has to be repeated so many times until the whole root is numbered. And if anyone can do it, can do this in just one table with one formula, I would be interested to see. I just didn't want to spend too much time trying to work it out, because I just wanted it was basically just needed for presentation purposes. It wasn't the main goal of solving this puzzle, but we would be really interested to see if this can be done in one table, one formula. But this is my like kind of a cheating way. So let's get to the end. Okay, so finally okay. It's not okay. So if I'm at the far end of the iterations, then it gets me right to the end. And obviously now the formatting is based on those numbers are linked to the corresponding number in this cell, and only the formatting only works on as many E's as this number is. So 6, 7, and so on. So that's the how this works. And now I will create a new sample and show you how to create this maze. Okay, so now how to create the maze. This is quite cool. Disclaimer, this is not my idea. I saw this somewhere on YouTube. Unfortunately, I don't remember, and I can't find this video anymore, so I cannot give credit to the person. But obviously, not obviously, but it wasn't created in Excel. It was just how to draw a maze, any maze. So I just adapted the idea for Excel purposes. So it kind of combined the initial technique. How to do it is not mine, but how to do it in Excel is my adaptation of this. Okay, so we have a frame which which is basically a set of rectangles, unbroken for to start with. And originally I had one for the outer frame and two for the inner walls, but later I replaced it with F and B, but that doesn't matter, the idea is still the same. So we've got this, so we basically have a because if I do B here now, no, 2, then so basically the whole area is conditionally formatted to mark anything that I put as a frame or as a inner wall as kind of with a color, so it visually looks like a border. So I've got, so this is our starting point, just full rectangles inside each other. It can be any, it doesn't have to look like this, it can be any similar setting. Now we add holes, just basically just delete the letter or number behind it. So we have a start, we have the end, exit, and then we create just random holes anywhere we want, as many as we want. Then I'm using the draw function to determine how I want it to, because oh, it was actually glued together. Okay, but I'm just going to do a different one. Let's just say I want completely different route, not like this, the red one. Maybe I want it to go like this and like this, very simple, and be out. Okay, so that's the route that I want. This is the solution that I want. And now the next step would be to block all the other ways. So for my solution, this is not a valid maze at the moment because I want it to go here, but it could go here, it could go here, and so on. So I will have to block this. I will have to, I want it to go down here, so I have to block it somewhere here, and so on. So I'm basically blocking it from going the route that I do not want it to go. So that's the idea. So these are my blocks, and I have to make sure that this is a valid maze, and no multiple options to go through are possible. Like this one actually at this stage is not no, it is, because if I go, I cannot go up here because I will hit a dead end or a wall. Here as well, I can't go here, I can't go here, I have to go. Okay, that looks good. And then remove. Okay, I'm just removing the root because that was just only to create the maze and make sure it's valid, and I no longer need it. It's not consequential for how the formulas work. So let's create a new sample and see how that works in action. Okay, so I'm going to create brand new sample based on what I've just explained. So let's just make a copy of this one to have all the formulas in place. I'll just mark it a different color. Okay, so I'm going into mode create, so none of the formatting will appear, perhaps except the start, but this is a minor bug. It should probably be still, well, it can be. Okay, so create. So I'm going to rather than doing the this from scratch, I'm just going to borrow the very first template. So paste values, and I'm going to now replace 1 with F, because that's what I changed my mind. I didn't work with 1 and 2s. I worked with F for frame and B for inner wall, like borders. So replace all, and then 2 will be replaced with B. Okay. Now the next step was to create random holes. So I'm going to pause and do some more of these, basically just deleting the entry. Okay, so I've got quite a few of those. Let's just do one more. I've created just random holes, and now I'm going to decide what route I want this one to go through. I forgot to actually make the entry and exit. Okay, so let's give it a route. So I would like it to go down, and maybe even though I'm close to the exit, I will want to go back up, and maybe like this, and like this. Let's just keep it like this. Okay. And now I have to block all the invalid, all other possibilities. So I want to force it to go this way. So I need to block it from going up anywhere here. It doesn't matter where. So I'm going to put the B back in for the wall. So if it turns this way, then it will hit a dead end. Likewise, it could possibly go here, and I don't want it to go here, so I will block this way. But it could still go here, so I'll block it somewhere here, and so on. Again, I'm going to pause it and just do the blocking. So I've created some of the blocks, and I don't think I've created enough, but as a quick way to check if this is a valid maze, I can actually solve it. So let's go to like possibly last iteration, and then go for solve mode, and you can see the route spilled. There is loads like this area in particular, this area. So that means why did it spill? Because I wanted this to go this way, but it could possibly go there and loop, and I don't want it to loop, so I will have to block it here. So that way this helps me, the solve mode helps me to actually see if the solution would work and why it wouldn't. Like here, I want it to go all the way, but it actually has a shortcut, which it would want to use. So I'm going to block that shortcut with B, and so on. So that's how we maybe like this one as well. And now this one somewhere here, block it. And there shouldn't be any spill here either. So now it looks like it's a clean way. So actually creating this, we shouldn't be solving it to create it. So it's a kind of a chicken and egg situation, but it helps me to see if I have a valid maze. But then, then it just gets. Actually, it is solved already, as we can see, but the cool thing about it is that now I can just delete this and see the solution, the route being revealed one by one, and it now goes. Obviously, it's possible, and that's how it should be done, to create the maze without solving it first, because you can just see if you have a valid route or if there are possibilities to go where you don't want it to go. Finally, a section about the non-VBA part of this. So I claim that I solved this puzzle without VBA, which is true. The file is not macro enabled. However, I am using the spin button only for presentation purposes, because actually the puzzle, if I ignore this button, if I just enter the final iteration here, that's our solution. But it's not as nicely looking, it's not dynamic for presentation, like for a post. For a post I wanted it to go one by one. That's why, so I would have to like enter 1, then 2, then 3, then 4 if I didn't want to use the spin button, which would be obviously not very efficient. It would take me forever. However, I would still do it, and then I would just speed up the video for presentation. So then it would be really, truly non-VBA. I don't consider using this a VBA, but it does sit in the developer, that button does sit in the developer tab, so that challenged me actually to create an alternative solution. So let's go back to, so the original presentation based on using the spin button was referring to control, which is this cell here. So now I've created an alternative solution without the spin button, and I called this one control now. So I'm going to change all these temporarily to control now. Okay. Right. So we're going to jump here. So this is a new tab. So instead of using a control button, I'm sure there are many more creative ways of doing this. I went for using the now function. It is not pretty, it is a bit clunky, but it works. So instead of using the spin button, I'm using a control function, which unfortunately doesn't update automatically unless there's something else for Excel to calculate. So I will have to I'll just go to any cell and I'll have to keep hitting the delete key for it to automate, and this box will give me the iterations needed, and as you can see the action is happening here, and this is linked to here based on the next minute chosen, because to have a nice start from the very beginning to the end rather than jumping halfway through, we would want to wait till 1 full minute passes and a new one starts. So we are now in 46 seconds into 41st first minute, so I'll just wait till 42nd minute of this hour starts, which is soon, and then okay, briefly it's showing me the full solution. I'm not bothered by that, and then it starts going one by one. I'm pressing this, keep pressing it down rather than holding it, because my computer is a bit slow and it keeps kind of jumping through the numbers, but it still has the same effect as the spin button, although not as smooth and as pretty, but it works, it does the job. Okay, so this is it. This is the behind the scene of these puzzles, of this maze puzzle. I'm working on the next one, so watch the space. It will be revealed soon. Bye.